with partners and independently. And so we wanted to share with you some of what we found in our engagements with DHS, with the airports themselves, and through some of our partners. Airports are a unique, certainly a unique animal. And, you know, we want to, there we go. We want to be sure and give credit where credit's due to all the people that are doing their best to defend these highly vulnerable, very critical transportation centers. So before we go too far, I want to point out this quote from Gartner. We didn't call the existing network infrastructure broken. They did. And it really is a key element in understanding how to move to a zero trust environment. I think at this point, everybody kind of knows or heard of what zero trust is. And it was born really out of the intelligence community and Department of Defense. It's a framework, it's a way of life. And we're going to touch on that a little bit because it's not a solution. There's a lot of products that can contribute to getting you to a zero trust state. The challenge really for airports is mostly the network. And I'm not saying that because we're in a network business. I'm saying that because when you really step back and take a look, and we're going to go through it here, you'll see that that's what's really creating the complexity and the hurdles to getting to where we need to be. So I was going to name this Airport Madness when I first looked at it, because it's a frightening reality for all of us. I think if most people knew what an airport network looked like, they would be concerned. And again, I think TSA, the municipality, are doing everything they can with the existing tools and budgets that they have to try to protect this environment. But we're really at a point where 30 years of open connectivity has really put us at risk because of the multitude of vendors and people that are in here. So quick background on us. I started this business 6 years ago with a gentleman named Alan Wade, who was CIO at the CIA and first CIO at DNI. And the business is really designed around improving secured communications, making it easier to deploy. Marianne, quick background.
Hi, Marianne Mines. I run our public sector initiative and kind of running the cyber critical infrastructure SME role across a lot of our accounts and validation activities, and have a great background in critical infrastructure, cybersecurity that spans a number of super companies. Mostly my career has been a contractor supporting government mission, and that's it for now.
Okay, so I think everybody's aware at this point because of the pipeline and how much has been highlighted around operational technology, and that's making airports as well as water treatment plants, dams, and power plants and all of it a more attractive target. I'm going to throw some numbers out here from the Department of Defense, that will kind of lay out why this is such an issue. But before we go too far, why don't we talk a little bit about zero trust? I mentioned that it's a framework, it's a way of life. It really starts with not trusting anything. Devices, people, systems, and networks primarily. That's the easiest way to break it down. The difficulty for all of us in getting to a zero trust framework and a way of life is that it's unlike other transitions in the past. This is not going to be a growth process. This is going to be a grieving process that causes us to part with a lot of the technologies and beliefs that we've held for the last 30 years. So denial, anger, negotiation, depression, and acceptance are going to be part of our hurdle in getting through those as quickly as possible. So what happened? How did we get here? 30 years ago, the gun went off and we all started scrambling for connectivity. And unfortunately, we didn't take enough time to look at security, and we just kept running. So up until now, the pain really has not been severe enough And we've been desensitized to what's out there. We expect power to appear when we plug in, lights to go on when we flick a switch, and water to come out of the tap. And without really considering the complexity and vulnerability of the systems that run all this. We started with simple human communications to get email across, and that's become very overwhelmingly large and complex. And at this point, moving to a zero trust framework, if it's done right, will actually simplify things and make things easier, and allow us to spend money on the more difficult cybersecurity tasks. So how do we fix the problem? First, we need to understand, like I said, that everybody's doing what they can with the tools that they have. The market is in transition. And I say this as one of the vendors in the marketplace. We are all talking about zero trust solutions, but if you really look around, not many have been implemented. And it's simply because we're at that phase in the marketplace where we're going through evaluations and new products are coming out, new ideas are being tested. So there's going to be an open-mindedness that's needed on everybody's part in order to be able to open the door to this. The mindset has to be not only do we need to look at new things, but we have to take a national security approach to everything we do. I say very frequently, I do a fair amount of public speaking here on the company's behalf, and I tell everybody, there are no children in basements anymore. I mean, there are, and they're certainly trying to hack, but hacking is a professional, very sophisticated business, and it's run by nation states with a lot of money, a lot of smarts, and it's constantly adapting, evolving, and advancing. So anything short of national security grade protection is going to leave us vulnerable. We have to get through the process that I mentioned as quickly as possible. And since everything is new and being built, it's worthwhile to obviously track with people like Forrester and Gartner, but I also highly recommend organizations like MITRE, who are not just looking at the marketplace, looking at data, they're actually doing hands-on lab testing. And there's quite a few of them out there. The Army Crypto Modernization Lab up in Aberdeen. MISI is an excellent source for not only looking at what's coming out of the government, but to gain guidance. So we're grateful to be a part of this. So thank you all, Carissa, Armando, and crew. We really appreciate being able to work with you guys on this. So let's talk about why airports are a perfect example. On the surface, we all go through airports with the idea that we're getting from point A to point B. We get there pretty easily. There's visible physical security to convince us that this is a place we can walk through with confidence. And TSA does an outstanding job. We hear about the gaps, but it's still the safest way to travel, right? But I think we need to keep in mind that all of that can change very, very quickly. The cybersecurity that we don't see is what we need to fear the most. Failures can result not just in loss of personal data and identity theft, but in lives, right? And I think that that's front and center when it comes to places like airports, train stations. We can fix this, we can get on top of it, but we need to really start running hand in hand to do it. Collaboration is important. So what do the bad guys see when they look at an airport? First of all, there's multiple tenants in an airport. This is not one organization or even one or two organizations sharing the same building doing IT stuff. This is TSA, FAA, customs, not to mention all the local police, government, vendors. You got the municipality involved. So on these same wires, and frequently, almost exclusively, these wires are old, with the exception of very new airports. We're all working with the same infrastructure, right? So physical security and building automation, and now we're bringing more stuff into play like kiosks, and God knows the public wireless is there, right? So Again, everybody's doing their best. Money's an issue. But the more systems and the more things that we bring on these wires, put on these wires, the more difficult it's going to be for us to protect this environment and the people who use it, right? So advancing is hard enough with government regulations and stipulations that are being imposed. But the good news is with this new initiative, the president's order, the infrastructure bill, we should be seeing a much more coordinated effort. I'm happy to say I see the government taking a real lead here. I think for a long time, Silicon Valley led with innovations and pushed stuff out, and the government tried to turn it into standards as quickly as they could. And I think this time we're going to see the government take a much more active role in this, and it's going to move out into the commercial environment much more quickly than it has in the past. So security is finally a priority. So I wanted to touch on the big picture here, and I'm going to use DoD as an example. Some of you may have seen this data, but I'm also going to show you in here how we chose to deal with this environment. So if we look at the IT and OT attack surface, and I'm including OT in this operational technology because, quite frankly, airports have a ton of it. And there's a lot of legacy equipment out there. So what I tried to do was just break this up into reasonable chunks so that we could take a look at the entire enterprise attack surface or the entire facility attack surface, right? So if we look at the Department of Defense as an example, there are 10 million IT points of access on the top of this chart. That's laptops, desktops, websites, and those are broken up into a very well-structured but complex to manage IT network. Running on the same wires. We've got the physical security and building automation and all this line of business stuff. And I will point out that it's difficult enough for us as a nation to defend Windows and Linux. But the number of operating systems in the OT space is upwards of 90,000. So there's a lot more complexity, diversity, and the age and manufacturers of these devices. Some of the devices we use were manufactured by companies that are no longer in business. And we're doing the best we can to maintain it. And a lot of that, in terms of the knowledge, is stuff that we just can't expect a typical CIO to be able to grasp. So when we look at these pieces, because of the volume, the approach that we took to this was every CIO wants converged data. They all want to be able to make decisions based on the most current information and have it in the proverbial single pane of glass. Well, at the same time, they're turning around to their network administrators and telling them to segment the network, break it up. And it's the right approach, but the tools that we have today, which were designed for a standard open architecture, are not adequate enough, which is why everybody in the industry, even the legacy players, are scrambling to change their offerings and develop new offerings and new technologies that can deal with this. So when we break these things up and we look at them as segments, when we first developed our solution, we looked at where the cost was. And if you look at this chart in red, this is where most of the IT cost lies. Access control lists, certificates and management, the policies around detection. And if you combine that already costly segment of the network and the airport budget, and you look at the diversity and complexity of OT, it tells you right away that this is not a good mix. And that for us to really protect entire bodies of technology here, we're going to need to start to simplify the network. And that may mean breaking it into pieces, because you need a single pane of glass, doesn't mean you necessarily need a single network. People in the intelligence community and Department of Defense manage multiple networks running on the same wires all the time. They've just been doing it for 30 years. They've gotten good at it. The equipment that they use is a little expensive, and the clearances and stuff that are involved make it expensive. So that's the area that we attacked as a company to try to make this a little simpler. So what we do, and this can be done in a variety of ways, but this is exactly the way NIST, if you go through and read the NIST architecture, one of the recommended implementations for Zero Trust is to use gateways to create enclaves. And these enclaves can create simplified network segments and entire networks. And again, there's multiple ways to do it, but it's the process here that I think we want to stick to, because in taking this kind of approach, we can move entire areas of technology out of harm's way, which will not only reduce our costs, but give us much improved protection and buy us a lot more time to deal with this massive amount of equipment that's sitting there. So again, Gardner said this is obsolete. We go in and take that Zero Trust and Zero Trust network and zone approach to that and apply it to an environment like this. And we can start to separate the enterprise easily. Now you can see we're doing something like this in an airport where there should be multiple networks can be easily adopted and implemented, right? And some of it's going to take coordination on the part of vendors, municipality, and TSA. But it's a collaborative approach that we can take a step at a time together and still have a pretty big impact quickly. This is just a use case. I'll tell you, this is one place where we applied what we're doing to an Air Force use case. And what you're seeing here is, last week, Marianne and I were in Las Vegas, and we proposed a new Flightline implementation for the U.S. Air Force. We even were able to get all of this stuff, they were talking about into a flyaway case. I don't know if any of you have seen these, but there are suitcases now with multiple server cards in them. We had a box with us that fit 10 server cards into it. And we're literally able to deploy a cloud and an entire flight line full of applications in a box. Closed network, deployed over multiple. Okay, must be somebody else.
Thursday. I think I'm very short.
There's questions, if you could mute, that'd be great.
So let's go back for a second, take a step back, all the way back to the initial architecture created by NIST, which is the underlying foundation in all of the architectures, whether it's come from MITRE, Forrester, or DOD, DISA, NSA. The premises is still, the foundational components, premises are still the same. And all of us, as we move to a Zero Trust framework, are going to have to map to what's on the right of this screen, right? That's really the underlying architecture from NIST in that 70-page 800-207 document. Well, what we did when we built our product was we took it and we mapped to that. We tried to make sure that we built an integrated solution that tied these pieces together to make it easier so that the average CIO, CISO, CTO, or line of business operational technology owner wouldn't have to spend an exorbitant amount of time and money doing their own integration. So, but the point is we all need to map to what's on the right, okay? Quick piece on us. Again, we did this. I'll just show you this is how we match NIST did. Our edge device is a gateway. Our broker is a bridge that ties gateways together. We have a management stack for it and monitoring. A full-time continuous monitoring component that's integrated in with the isolation and containment, the micro-segmentation, if you would, for the platform. So when we build a network, this is how we go about doing it. Take the edge device, the gateway, grab a network segment. That network segment's now running in its own network. That's tied to a broker, which will allow us to tie to other network segments and create a full-blown network. And you could see where we could go into an airport and apply this process. Again, forget our product for a second, but being able to apply this process to a multi-tenant environment would give everybody independence, security, and the key is to be able to really separate the networks on the wires. And then once it's done, you can add continuous monitoring. We have our platform, but we also integrate with a lot of products that are out there, like Microsoft Defender, Tragos, Forescout, Darktrace, to name a few. Doing it practically, the Department of Defense's National Cyber Range handed us the same challenge that protect the OT. We simply took the two boxes which have all the OT in it and broke it into pieces. Now, this is unconventional networking. There's no two ways about it. This is not, and when we talk about applying this to IT, we need to take into consideration managing the network from the cloud, and OTL is about to make its own migration to the cloud, managing networks from there, bringing a security stack down to the edge device. In our case, it would be the device we're installed in, but we want to get the security stack from the enterprise, from the cloud, down as close to the edge as we can, so we can learn everything we need to and provide the best protection possible by being able to do the right analytics and apply the right solutions as they pop up across the enterprise. And then, taking that and putting it out again practically. This is the airport use case, right? Typical municipal, local, international airport, right? So that was kind of a significant amount of information. So why don't I take a breath, take a sip of water here because I'm losing my voice a little bit. And why don't we field some questions from you guys? Anybody have any questions?
If you have questions, please come off mute and ask your question. Oh, you do have a question in the chat. Is this only cloud solution or also available on-prem?
Oh, no, it's available on premise. In fact, that was one of the things that I mentioned. The Flyway case is a mobile solution. So I think there's some very interesting opportunities for us to bring cloud-based solutions and management anywhere with us. But yeah, I would say that right now, half of our implementations, we just kicked off a power plant down at Fort Belvoir for the Army, where we're going to be lifting a microgrid out of the existing IT infrastructure. And we're working with Schweitzer, who's running their software-defined network right inside of our ZeroTrust network. And that's all on premise. But there's still, again, because of the way we approach communications, believe it or not, we can actually provide remote access for that microgrid. And we're going to be doing that for folks who want to see it in various parts of the country.
Are there any
your question
at this time? We have a demo.
Yeah. So if you guys would like to see a demo, how this stuff can be set up, configured, how we approach the problem, we set some time aside here to show you if you guys have interest. So we have some time. So you want to kick off and hand it off to Christina. Christina, you out there?
I'm here, Glenn. All
Right.
set and ready to go.
All right.
And so we should introduce Christina as well. She works with our engineering team and has been responsible for a lot of the hack the planet, hack the building, and now, hack the airport in terms of the, the practical application of this capability applied to scenarios. So with that, we'll work through, and we're kind of working from a couple different locations right now. So Glenn and I are at Crystal City office at the moment, and Christina's back at our Tyson's office.
All right, so Christina, take it away. I just handed you the pen.
Yeah, we just had the demo up, but it disappeared.
Okay.
Okay.
So that's part of what we do. We make networks and devices disappear so that you can't get to this, can't get
It
to
was
the
there.
attack surface. So you've just witnessed what a hacker would see trying to get to our network
Or not see.
or not see.
That's right. That's good. And just so folks know, as you're thinking of questions, feel free to pop out anytime. But we have a couple permanent demonstration locations in the DC metro area. One, we're attached to CyberBytes, which is the Quantico Cyber Hub, and we have our demonstration capability attached to the Industrial Control Systems Village and the second floor, demo suite, if you've been there. And then working to stand up really this month with Missy. So we'll be attached to that demonstration capability and a number of other demonstration partners, as Glenn had mentioned. So let us know if you ever want to come in and see a kind of hands-on experience applied to a particular use case. And Christina, let me know when you're ready. Otherwise, I'll keep talking for a second. But we really, this zero trust approach, and not just our tool, but really the zero trust approach is very important to critical infrastructure protection and the cybersecurity of operational technology. So we are a horizontal solution. Zero trust should be a horizontal solution and really fit to the mission and the applied use case as it pertains to that particular critical infrastructure domain. And if you'd like more information about critical infrastructure and the domains and the sectors that were set up by Department of Homeland Security, there's some great resources out there. And we have a number of links that we'll be happy to provide you with that are great resources across DHS, NIST, and other kind of national offices that are focused on this imperative. Okay, with that, Christine, are you ready to go?
Yes, I'm ready. And I just want to make sure that what everybody sees on their screen is our part of our demonstration environment, which
We can see it.
shows 2 Enclave trusted edges and a group of hardware here and an access pinhole camera. If everyone can see that, then I'm going to start. And if you have any questions, please feel free to ask. So I'm just going to do a quick overview of what you see in front of you. There's a trusted edge here, what we call a trusted edge. There's another trusted edge on the side. This is a commingled network prior to implementing the Enclave trusted platform. So you have an Ethernet switch here and an Ethernet switch here. This one is powering the camera. They're linked together. There is an Intel NUC running as a server, running Windows 10. And that's actually going to be mimicking a camera server. One of the points that I want to make is that our solution is network agnostic in terms of internet circuits, in terms of bandwidth, outside of what we would expect in a regular environment. So that's this part, and I'm going to shift screens temporarily. And what you should be seeing on your screen is a Windows computer screen with a left window that says Manage Devices, and it shows 1 camera. And on the right half is the actual pinhole camera that I was mentioning earlier. So is that what everybody is currently seeing?
Yes.
Just making sure. Okay, so here is the pinhole camera in my hand. And as you can see, that's my fingertips, right? Real time. Again, commingled network. And what I'm going to do is I'm going to remove the camera from the commingled network as if we're putting implementing our Enclave trusted platform into an environment. So I'm going to disconnect the green cable. Plug it into there. I'll switch back. And as you see on the right side of the screen, the camera is no longer recording. The Intel NUC system cannot see the camera. The camera is actually going to maintain its existing IP address. It has been obfuscated from the outside network. What we're basically doing is creating an overlay network. I've been working with overlay networks in various forms for 20+ years. I even helped design or at least review the operational networks at for WMATA, for Reagan National, and for Dulles back in a previous life. So as you can see on the right frame, the camera has now gone offline. So now I'm going to move the Intel NUC from the commingled network to the other trusted edge, and we'll give that a minute. And in about 30-60 seconds, the camera will be rediscovered, and we should get a good quality. Let's see if I can reload that, make it faster. We're waiting, we're waiting. Okay, it should be between 30 and 60 seconds. Sometimes it takes a little longer. And there we go. So camera is back up there. So this is one camera in this environment. Now, what you don't see is the fact that our trusted edges are communicating to a trusted broker. This is actually an on-premise deployment, not a cloud-based one. Our brokers are actually in our data center in Ashburn, Virginia at Equinix. And we have multiple trusted edges around that have been deployed for this demonstration network. So what I'm going to do is scan for other cameras or other protected devices in this overlay network. And as this is coming, you're seeing on the left frame, you should be seeing a couple extra devices coming in. I'll just wait maybe one more. And these are geographically dispersed. We can have devices, whether they're cameras or servers or laptops, whether it's in Virginia or in Washington, DC, or in Germany, any location. And I'm going to add these into the system database, and then I'm going to pull up a couple extra, at least one extra camera to provide an idea of what you can do with this solution. And great. There's the panel again. So that's the highway outside. That is the Dulles Toll Road outside of our Tyson's office. And this one is looking downtown. I will pull up the Kennedy Center and give an even better idea. Let's see. And there's the U.S. Capitol. So this, one of the things that we found out quite inadvertently was that implementing our solution actually reduced jitter and loss of synchronization with the cameras. What we actually can now do with our solution, as a side effect, again, is match the speaking pattern to the and from someone speaking, and actually match it up to their mouth movement to verify. So someone who's lip reading can will actually see that, or someone who's hearing it will see that they're all synchronized. Again, this solution can be deployed geographically. You can do you don't have to do just cameras. You can do temperature sensors. You can do door controls. You can set up, as Glenn was explaining, the Flightline in a box, which was a very fun project to set up that piece of hardware. those can, again, you can have all on-prem, all cloud, or mostly cloud, or a hybrid environment. We've deployed these in several different locations for several channel partners, and having hybrid environments seems to be the best option for us. But we also are aware that there are organizations that would require a completely on-prem solution. This is the very quick version of our demo. I can actually, if people are interested, I can demonstrate additional components of the solution. And commentary, anybody, questions?
Christina, while we wait for questions to come through, I wanted to also share that Christina was involved in back in 2018, where the Enclave platform was entered into the first Hack the Planet Industrial Control Systems Village kind of capture the flag event. And there were over 50 teams with multiple participants on each team. It was 48-hour challenge. And the way the challenge was set up is, if you're familiar with the Industrial Control Systems Village and its presence at a DEF CON type of event, it was a remarkable, like, mini city of various infrastructure components, to include IoT devices of any type and size that would be maybe in a facilities related control systems dynamic or a building automation system use case, all the way to water treatment plant, PLCs, et cetera. And we actually entered and I'm sorry, my phone's ringing off the hook. We entered an access camera protected by an Enclave trusted edge. And I'll let Christina tell the story. Honestly, it was pretty remarkable that we were the only device that wasn't captured during that challenge. But go ahead and maybe talk a little bit about the components of that challenge.
So, Marianne, thank you very much. So a little bit more background on me. I'm Christina, as Vice President of Technology here at Enclave Networks. Marianne is absolutely correct. We did go to DEF CON 26. We did have a single camera protected. What we were doing for monitoring, that camera was exposed for the ICS Village Capture the Flag event. We were monitoring the camera both inside the secure enclave and outside the secure enclave to determine if anybody had broken into it, or it was the goal of the capture of the flag was just to find the hardware address. There wasn't even a requirement to hack the camera itself, but if they'd found the MAC address, they would probably be able to get the IP address and therefore display it on screen. Nobody was able to do that. Monitoring both the outside of the secured environment and the inside determined that nobody was able to figure out how our Enclave Trusted Edge boxes were actually protecting the camera. They tried all of the traditional easy, everyone did all the easy reconnaissance, attacks, and then they kept on trying to do harder and harder things, but they weren't able to actually get through the box. And at that point, because they wanted to make sure they got everything else done, they stopped trying to find the box and then cleared out all of the other challenges in the capture of the flag, and then came back to our box and still weren't able to get into it. So in a nutshell, I did a demonstration of the Enclave platform for the Hack the Capitol event earlier this summer, and that was well received. Since I don't have any questions yet, I'm going to change screens, and what you're now seeing is what we call our trusted orchestrator. Our trusted orchestrator is our policy engine, which is used to create the secure enclaves. There are different things that happen in the orchestrator, in the trusted orchestrator. One of which is you create the secure enclaves. You register the devices, which is a trusted broker, a trusted edge. There are unmanaged devices as well in here. But as you can see on your screen, there are, yes, they're listed as gateways and bridges that we're changing our terminology. But everything here that's marked as secured is actually inside a secure enclave. So I'm going to jump to the secure enclave, and the secure enclave encompasses the demonstration cameras that you were looking at, including the one that is protected, that was allowing you to see the US Capitol, is in this environment here. Again, this is our policy engine. So you have a trusted orchestrator, you can have 20, 30, 50 policies include for different brokers and different trusted edges, depending on how you want to create your overlay networks. The important piece here is the topology tab, and that shows that there are 2 trusted brokers in this, creating this secure enclave. The 2 trusted brokers are functioning as active, and one's the active one and one's the backup. And then what you see here is the list of the trusted edges. We can also put our code directly on Axis cameras, Raspberry Pis. If the device can support a TPM chipset, we can build that in to use the TPM directly. Otherwise, we can virtualize the TPM itself. That's actually part of our security model. All these devices that are listed as secured are trusted edges that are functioning. The ones that are marked as transition to trusted are currently offline. But what's important on this screen is that it's really simple to add another trusted edge to the secured environment, so you can then extend your secured network to a new building, a new floor, a new wiring closet, whether it's a camera, again, a temperature sensor, a laptop that's needed to securely monitor. For example, we have a client that we have provided secure access from a remote location to monitor cameras with after hours inside the government building. And so that organization is responsible for monitoring the cameras from 7 p.m. at night to 7 a.m. in the morning. And for them, the ability is we can add additional trusted edge boxes to add additional cameras. That's the critical takeaway here. One of the other things you'll see here is the assigned DMS. The DMS is our discovery and monitoring system. It is our rules engine. The point of the rules engine is to create alerts on devices such as unknown devices that have been introduced into a secured network, which is something that is very important to find out, because everyone's expecting that their network is secure. If an unknown device shows up, then someone is potentially making either a cabling mistake or is actually trying to break into your network. Alerts from the DMS actually will end up here, and these alerts are showing the hardware address of the device, what kind of device it is, the date of the alarm, and actually the code. In this case, it's an unknown device. These are actually, again, for our demonstration network. And then we can resolve the alerts here. When we resolve an alert in the trusted orchestrator, we then whitelist that MAC address, and then we start profiling the device for its traffic patterns. When we have enough data which is generally a week, profiling the device allows us to determine unusual traffic. And then if you get different kind of alert, will be an alert for unusual traffic, which only exists for whitelisted devices. Those kinds of alerts are important because that's how we detect a device that has either been compromised or is trying to reach out, or was compromised prior to inclusion in the secured enclave and is trying to reach out to IP addresses or other devices in other networks, like prior to being put into the secure enclave. Are there any questions?
If you have any questions, feel free to drop them in the chat. If not, you can come off mute and ask directly.
We have one more slide. Yeah.
Marianne and Glenn, back to you. I yield the floor.
Right. Yeah. I think we had one little.
We just
kind of
had
wrap
one
it up
little slide to kind of wrap it up and say, that I think the value of implementing a zero trust framework and moving to a secure access service edge where the networks are managed in the cloud and the security stack comes down to the edge. The value to airports is because of this complexity in a way, airports have to accommodate all this legacy equipment and people. Oh, sorry.
He's gonna bring up the slide that we're looking at.
I was going to try to.
You can do that.
Anyway, the point is there's as we start to advance with zero trust, I would expect to see airports in the forefront, really, to get moved in this direction. The difficult part for airports is going to be the multitude of people that are there, right? Getting the federal government, municipalities, local police, everybody together to agree to move and advance the facility as a structure forward is what's going to be difficult. I think that it'll be more about people than it will be about the technology, but it's a great example of why we need to move in this direction. And we're grateful to be a part of it and grateful to be here with Missy, and hope to see a real shift moving forward. So thank you all very much. We appreciate it. Christine, thank you for popping in.
Yeah, and we're happy to share the slides with anybody that would like to take this away. And I know Veronica's recording this session, so feel free to come back and listen to it again. And happy to help any way we can. Very committed to the training of the next generation cyber specialist, and happy to support training sessions at universities and any kind of other learning capability for you all.
Thank you. Thank you, Marianne. We really appreciate it. Thank you to you and the team, Christine, Glenn. As Marianne said, we will collect the slides and we will send them out to anybody who would like them. Also, feel free to register for any of the other training sessions today or tomorrow, where we're going to keep training our cyber warriors in preparation of the Hack the Airport event on Wednesday. So really appreciate it. And thank you all. Have a great day.
Thank you.